We are here to talk about the passport. Let me explain to you comfortably what the passport arrangement is. He thought of the easiest and simplest solution that everyone thinks of. He said, "What do you want?" I said, "A bus bar." He said, "Okay, I will do the same idea of the connection. So what will you do?" He said, "I will get a bus bar like this, a piece of bus bar in this shape, all right, and I will take from this piece of bus bar like this, all right, and go to what? Go to my load. All right, and as I go to my load, I will use an electrical circuit breaker here and go to my load, all right. Very good. So I have this as a bus bar. Don't worry, engineer. First of all, for the new participants who joined us, the lecture is recorded, so I will send you the download link for the video tomorrow morning, God willing. The second thing is the Indian engineering paper that I was using to explain in front of you. I will also send it to you in the group. So you don't need to draw along with me. All I want from you is to just focus. All right? Very good. Okay. Here you have the electrical busbar system, eh? And here you have your electrical cable connection, whether it's something bringing you, for example, or in this case. All right, and here is your cable, regardless. That's good. I told him it's nice. Okay, he said, "Look, sir, what problems are you facing?" I told him, "Let's see." He said to you, this view, the first thing is this bus bar, which is your connection, all right? So this connection, of course, has something that supplies it with power, and a group of other feeders take electricity from it. I told him, all right. He said, very good. Okay. Now, what happens is, if I connect all of these in a circuit without a circuit breaker, just like that, I've connected them in a circuit. Simply put, as I told you, the idea of the connection is exactly this. If you have any one of them with a problem, then the whole thing is messed up from your side. We must install a circuit breaker because this circuit breaker is used for two things. One of them is the connection or disconnection, exactly like that. One of them is the disconnection and connection where I want to control. I want to connect or disconnect as I wish. The second thing is that it is used for disconnection during protection. We will talk about each part in detail, don't worry. We will discuss them now, but I'm just explaining the main idea. He brought you a bus bar here and brought you what here? And he brought you a circuit breaker, and at the end you have the feeder, whether it's a cable or overhead transmission line, right? I said, right. He said, okay, the first thing is you have three problems here. I asked, what are the three problems? He said, if you have maintenance on this bus bar, meaning the maintenance, or we had to track down unexpected and unpredictable malfunctions due to what? Due to the presence of a fault. Okay, so now you had a fault occur on your bus bar and you want to start troubleshooting. For troubleshooting, of course, you want to conduct some tests and do a lot of things. Or if you're in maintenance, you've already disassembled or you want to perform maintenance on it. So you want to do cleaning operations, conduct some tests, and perform training operations and so on. I said, okay. And he told me, all right, that's the first point. What's the second point? The second point is that now, whether it's maintenance, troubleshooting, or a fault, as I mentioned, the second point is the breaker. The same applies to it if you want to perform maintenance or troubleshooting on it due to a fault. And lastly, the cable. It's the same idea, right? Quite simply, let's see together the first thing. If you have this passport and you want to do something with it, or if it's malfunctioning and you want to do something, then surely everything connected to this passport itself must be disconnected, right or wrong? You told me right. Okay, this means that I lost all my loads that are here just because I want to take this passport out for maintenance, or it has malfunctioned and I want to troubleshoot it. Of course, if it has malfunctioned, then obviously it has stopped working, regardless of whether you want to troubleshoot it or not. Regardless, if it has malfunctioned, then you definitely need to disconnect everything connected to it, just like your connection. If your connection is damaged, you will definitely remove everything from it. Okay, engineer, this will result in low reliability or poor dependability on it, which will be very bad. All right, very good. Let's continue. So, when it comes to the electrical component, you want to perform maintenance on it or you want to troubleshoot it. Now for this electrical component, this terminal has voltage on it. All right, and this other terminal, this cable might have a load on it, meaning this bus bar could be something receiving from an incomer and supplying your load, or it could be that what is coming here is your supply feeding the bus bar. So either this side or that side will be live. That's why I wrote the letter V and left it as live. All right, consequently, because both are live or one of them is live, you can't work on this setup. Therefore, what needs to happen is you must disconnect both sides. You can never work here on the breaker and the bus bar while it's live, nor can you work on this while the video you have is live. The last thing, your cable, your load here, or this cable if you want to do the isolation here, or it gets voltage and you're troubleshooting in both cases. This cable of yours is the same idea. What is the cable essentially? As I told you, the cable is something like this. If I take your cable or its cross-sectional area like this, here it is. The cable consists of this part here being an insulator. And the part in the middle is a conductor, and the outer part is also considered a conductor. So you have a conductor, and what's between them? This was a conductor, here it is. All right, and this is a conductor, and what's between them? There's an insulating material between them, right? So what does this represent for you? Capacitance. And as I mentioned, capacitance equals epsilon naught times epsilon r times the area over the distance. Of course, the distance in the cable is very small, so the capacitance is high, making it capable of storing an electric charge. So as soon as you start working here, what happens to you? You get an electrical shock. Is that clear, everyone? Great, my dear. So this shape has become the simplest form, right? What is this called then? Focus with me. It's called a single. Just a single, or maybe breaker. What does this mean? It means that your supply, whether you are going to a load or coming from a source, is in the form of your feeder or this setup. It is a bus bar coming out through one breaker, so it is a single bus, single breaker. All right, a single bus, single breaker. This setup, guys, is referred to as a feeder. Single bus, single breaker. This setup, guys, is referred to as a feeder. Or it is called a cell or a diameter, any of these names. Of course, people working at the Saudi Electricity Company might say this is a diameter for us at 380 kV, and this is for us at 132, 110, or 115, which is the high voltage, and the feeder is for us in the medium voltage. I'm telling you, you can call these three terms whatever you want. So this setup is called a feeder, regardless of whether the feeder supplies a bus bar or a load, it's called a feeder. Or it means a cell or a diameter, that's fine. Any name from those terms. So we call this a single bus, single breaker, meaning the supply is done either way through just one bus bar with a single breaker. All right, not forgetting, great, we have seen together, let's see, we have seen together this form, which is the single bus, single breaker that you saw with me here. All right, great, look with me up here at my system. It said, well, quite simply, I can improve this or adjust this. This system is very simple, very cheap. Very simple and very bad in every way, but in the problems or challenges we have seen, the bus bar itself might be under maintenance or have voltage, so you need to do troubleshooting, or the breaker might be under maintenance or have voltage, and you want to do troubleshooting, or the cable itself was under maintenance and you want to do troubleshooting. In these three situations, or with these three components, if you want to work on any one of them in your station, whether it's the bus bar or the breaker, apart from these two, you are forced to disconnect the entire bar. This means taking the entire station offline. As for the cable, there's no problem. You can isolate the breaker and work on the cable without any issue. Of course, you might have another problem, but in terms of capacity with the charges, they said, what should we do? They said, okay, it's very simple. Instead of the station being just a single connection, which is only one bus bar that everything is connected to, I can divide it into one bar and another bar, meaning I can divide it into 2, 3, or 4 bars. For example, in this station, I have 3 power sources and 17 feeders going to supply different loads, regardless of what they are. So in total, I have 20 feeders, right? Or 3, well, Why not divide them into three? Make them 3 bars, each bar having a power source. So each power source and bar, for example, has 7 loads, another has 6, and another has 7. This way, you've divided the same station. You know the idea when someone tells you that you have a big problem, break it down into a set of smaller problems, and you can solve each one individually. It's the same concept. You divided them into 3 bars. Each bar has a power source and a set of feeders on it. Very good. Okay, so the first thing is I divided this bar into several parts, right? And then also, come on, between each bar and the other bar, okay. Now, engineer, if you still have a problem in one bar, you would now lose 1/3 of the station, I'll tell you, right? Instead of losing the entire station or losing 1/4 of the station, if you divided this bar into 4 parts as well. So engineers, very good. Okay, so we are now, Ustad, let's continue. And we operate here like this and activate the circuit breaker for you. All right, so as an engineer here, you will have this setup where you bring another bar and move like this, then a 3rd bar and move like this and so on. All right, so this is the 1st bar, this is the 2nd bar, and this is the 3rd bar. So you have divided the same bar. Therefore, if you have maintenance or troubleshooting on this bar, you only need to shut down 1/3 of the station instead of the entire station, right? I told him exactly that's right. He said to me, all right, and then what, engineer? I told him it's very simple. I said, now, if you don't have maintenance or troubleshooting, but this feeder or this supply, which is the generator or the incoming power to this bar, let's assume it has an issue, or I will perform maintenance on it. It makes sense to do maintenance on it. I would lose all the loads that were connected here when they were all together at first, all at once. I had the 3 sources available, so if one of them failed, the other 2 could supply. I want to achieve the same thing. All right, great. So what will you do? He said, look, quite simply, between each bar and the next, I will install an electrical breaker, and I will name this electrical breaker either tie, which comes from the necktie, or section, or coupler, depending on what each of you calls it in the place where you work. In the end, this breaker is an electrical breaker, and its function is simply to be a tie, a section, or a coupler. This necktie is what connects one thing to another, or a section as a result of dividing this bar into 2 sections. Or there are 2 different bars, so you create coupling between them by connecting the 2 together, thus creating coupling between them. In this case, what is the purpose of this breaker? The purpose of this breaker is to close in order to allow for the sharing of power, meaning the sharing of your power capacity between the bus bar and the other bus bar. This way, if one of the bus bars has its source go out of service, the source here can share, or these 2 together can close this breaker and that breaker, so these 2 can share the loads of the 3 bars, or it could be that one of the bars, for example, has a very heavy load on it, while the other 2 bars have some loads disconnected, resulting in a lighter load. So what's the problem with letting them share their power with the 3rd bar? All right, so what's the purpose of this? The purpose of the bus. Okay, I've solved the maintenance and troubleshooting problem in high voltage situations. If I have maintenance or a fault on this bar, instead of losing the entire station, I would lose 1/4, 1/3, or half of the station, depending on how many bars I have divided it into. Of course, this doesn't mean I've solved the entire problem, just a part of it. Instead of losing all the power, I would lose 1/3, half, or 1/4 of the power. Very good. But why did I install the bus section? So that I can share power between the different bars. With this bar, in case the source here is absent, disconnected from service, or under maintenance, or in case you have a heavy load here and light loads on the other side. So this is the story of the bus section. All right, that's the first part. Now, the second part, regarding the breaker. Is it reasonable now, Engineer Rashad, to work on this breaker and disconnect the entire bar just to work on a single load on one breaker for maintenance or troubleshooting? Disconnect the whole bar. What do you want? I told him it's very simple. I'll do something simple. What's this simple thing? He said, first of all, as long as you still have the idea that you might lose 1/3, 1/4, or half of the power, then its reliability is poor. All right, so its reliability is not good, and therefore I can't use it with high and extra high voltage, because the high and extra high voltage, as you explained to us, are responsible for what? They are responsible for
transmitting power, right? We said, am I wrong? We transmit power in the form of high or extra high voltage. So imagine with me, engineer, that in the bulk movement of power, if I disconnect a breaker, of course, I will definitely lose a large amount of power. However, if I use it in the distribution stage, meaning I only take a part of the power, then what controls it? Yes, that's why I make this system. For what? This system will be somewhat for what? Voltage applications. All right, engineer, I told him, that's very good. He said, great, what else do you want? I told him, well, as long as it's medium voltage, the size of the circuit breaker is reasonable for me, manageable, which can be handled by humans or through human intervention. So I will make this circuit breaker for you in such a way that it is something called withdrawable. The symbol I will draw for you means that it is withdrawable. What does withdrawable mean? It means it is retractable, like a drawer in a desk that can be pulled in and out of its place. Therefore, if you want to work on the breaker, you can pull the breaker rack out completely, meaning it is retractable. As I told you, what is it called? It's called a withdrawable breaker. Look up here with me so I can show you with the mouse. Here it is, a withdrawable circuit breaker. What does withdrawable mean? It means you can make it rack in or rack out. Rack in means going inside and rack out means going outside. So this is rack in or rack out, meaning you can insert or remove the breaker like a drawer. Therefore, in the case of breaker maintenance, I can pull it out, rack out, and perform maintenance on it without affecting the rest of the connected loads. On the same bus bar, okay, regarding the cable, Engineer Rashad, you mentioned it has high capacity and is prone to electrical charges. He said, yes, for this cable, you need to install something called a grounding switch. A grounding switch. When you close this grounding switch, what does it do? It discharges, connecting here with the conductor of this cable to discharge the electrical charges into the ground. This ensures that when you are working on the cable, you are safe or completely secure. This is called the grounding switch. That's great, guys. Nice. Okay.